you describe the history of this world, then evolution is described as a process. If you just describe the history of this world, then evolution is a process. If you are describing the life on this world, then evolution is nothing but the consequence of a process called natural selection. Okay, repeat once again. If you are describing evolution, that is in terms of the history of the world, then it is called actually a process. If you are talking about evolution, describing the evolution, as we see that one just when you are describing the life on this earth. Now evolution is nothing but the consequence of a process called natural selection. There is a difference between these two. Now we have evolution. This is nothing but the origin of life and a diversity of life among organisms over times. In course of time, new organisms have evolved from the parental generations. That means we can say change in the descendants. This is one aspect. Now we have different words used to describe evolution. So it may be described as what is called a change or roll out or unfolding. A single word referring to evolution, a change or roll out or unfolding. According to Charles Darwin, the father of evolution. So now evolution is descent with modifications. Descent with modifications. So this is according to Charles Darwin. Charles Darwin. He described evolution as descent with modifications. New species being formed because of the changes in their structural organization, because of the change in the genetic material. That is what's called descent with modification. That is a statement given by Charles Darwin to define evolution. Now there are two types of evolution. One, inorganic evolution. What is inorganic evolution? The development of complex matter from simple matter. So, simple to complex matter. Simple matter to complex matter. Simple to complex matter. This is also inorganic evolution. What do you mean by organic evolution? Evolution of complex organisms from simple organisms. Evolution of complex organisms from simple organisms. Complex organisms. This is called organic evolution. This is called organic evolution. So the complex organisms have been evolved from simplest forms of life, and that is called organic evolution. The concept of organic evolution was given by Herbert Spencer. The concept of organic evolution was given by Herbert Spencer. Okay, this is now the fundamental one. Now as per the book, you have also another definition. So normally evolution is used to describe what we have the heritable changes in one or more characters of the population of species from one generation to another generation. So evolution is used to describe, that is what we have normally heritable changes in one or more characteristics of a population of species from one generation to another generation. This is called evolution as per the book also. We can take into consideration of this definition too. Okay, now, suppose taking the origin of different things. For example, origin of universe, origin of earth and origin of life. Now the origin of earth took place nearly 15 billion years ago. Origin of universe. That occurred nearly 15 billion years ago. Now origin of earth Normally we can say 4.5 to 4.6 billion years ago. This is the origin of Earth. Then when did the life originate? So origin of life. It took place nearly 500 million years later. That is the origin of Earth. So roughly we can say 4 billion years ago. That is 500 million years later. Millions years later, after the origin of Earth. So 4.5. So after 500 million years later, we have the origin of life on this Earth. That is 4 billion years ago. These are some of the actually one of the concepts, the data. Now we have to consider the first one under the evolution. How did life came into this Earth? That is origin of life. Various theories have been proposed to explain the origin of life. One by one we can see what are the various theories used to explain the origin of life. Number one, special creation theory or theory of superstition. According to this concept, what will happen? The entire universe was created by God. If we are taking Hinduism, now the living things created by Brahma. We have different religions, Islam, Christianity, all believe that the origin of the universe was mainly created by God. That is called theory of special creation or theory of superstition. And normally it was taught by Father Swaras. Father Swaras. Now the next one, theory of abiogenesis or spontaneous generation. Now the living things actually originated from inorganic or non-living materials. Non-living materials. The non-living materials gave rise to the existing living forms. Existing living thing. This concept is called abiogenesis. So the origin of life from non-living materials. That is called existing living thing formed from the non-living materials that occurred, you see that one, through chemical and molecular evolution in a stepwise manner. So through a stepwise manner, by means of chemical and molecular evolution, we have formed the existing living thing. Now this concept was normally first started by Aristotle along with other people. But the term abiogenesis was given by Thomas Huxley. He only given the term what is called biogenesis. The term biogenesis was given by Thomas Huxley. So living things came from non-living materials over a period of time because of chemical and molecular evolution in a stepwise manner. Now biogenesis. Now here it is against what is called abiogenesis. The concept of abiogenesis was disproved. I use the word spontaneous generation naturally without any inducement. That is called spontaneous. So the word biogenesis refers to the origin of life from already pre-existing life. So pre-existing life gave rise to the present living or present life. This is called biogenesis. So it's all actually described the process of biochemical, that is reactions. Or we can say the biogenesis also used to describe the biochemical process of actually production of living organisms. Biochemical process of production of living organisms, that is called the biogenesis. So pre-existing life, already existing life gave rise to the present life. This is what's called biogenesis. Various experiments were conducted by different people. For example, Louis Pasteur, he conducted one experiment The name of the experiment is called Swan Neck Flask Experiment. Swan Neck Flask Experiment. Through this experiment, he proved that the life originated only from the existing life, not from inorganic materials. Other two persons contributed in different ways, conducted experiments were Splodani. Another person conducted experiment to prove the concept of biogenesis. And also another one, Francisco Rendi. So these three people normally explain the concept of biogenesis through different experiments. The famous experiment that was conducted by Louis Pasteur named as Swan Neck Flask Experiment, because the flask that was used for the experiment is having a long neck just like a swan neck. Okay, now the term biogenesis. So these were the people who conducted experiment to prove what is called the biogenesis concept and also to disprove the concept of abiogenesis. Now the term biogenesis was given by Henry Bastian. Henry Bastian. So the name biogenesis was given by Henry Bastian. The term abiogenesis was given by Thomas Huxley, and those conducted experiments to prove the concept of biogenesis were Louis Pasteur, Splodani, and then Francisco Rendi. So these were the three theories related to the origin of life. I will continue further. The next one, Big Bang theory. The next one is the Big Bang theory related to the origin of universe. Origin of universe. Now the origin of universe occurred through a single, that is what is called singular, what is called huge explosion in terms of physics. So you have the earth along with the universe, we have the entire mass having some internal forces. They undergo what is called explosion. A single huge explosion resulted in the formation of many planets. So we have the origin of the universe. This is because of, you see that one, a Big Bang that results nothing but a huge explosion. A single huge explosion resulted in the formation of the universe. Now if you are taking the primitive atmosphere, the primitive earth normally didn't have a proper primitive atmosphere. The primitive earth didn't have a proper primitive atmosphere. But we have various gases excepting oxygen. For example, ammonia, methane, hydrogen and water vapor. And this is not the first one. We had elements in the form of metallic carbides, metallic nitrates, etc. I didn't go through all these things. So we had, though the primitive earth had no proper atmosphere, but it contained ammonia, methane, hydrogen and water vapor. Now we see that one, we have energy in the form of UV radiations. The UV radiation split water molecules into oxygen and hydrogen. So this is what is happening. The UV ray, they were the sources of energy responsible for breaking a molecule of water to form oxygen and then hydrogen. Now I already mentioned we have, that is what we call the water vapor. So the climate of the primitive atmosphere was extremely high. For example, if you are taking the temperature, it is about 5,000 to 6,000 degrees Celsius. Okay, even if you are taking the temperature, it is high. So the climate of the primitive atmosphere was extremely high, having high temperature of 5,000 to 6,000 degrees Celsius. Now we have sudden cooling of the earth occurred. So that what happened? The water vapor contained in the atmosphere condensed to form water, rainwater. The rainwater was showered and then accumulated in the depressions. Then they became what is called the water bodies. That's about the formation of water bodies. Now we have the formation of oxygen because of the splitting of water. Now the free oxygen combines with, the free oxygen normally combined with, that is what we have ammonia and also methane. It combined with ammonia and also methane to produce carbon dioxide and other gases, for example nitrogen, etc. I'll explain later about how far the reactions occur. So reaction between methane and also ammonia occurred, resulted in the formation of carbon dioxide and other what we call the gases like nitrogen. That's about what we call the Big Bang theory and the origin of different water bodies, the molecules, etc. Now cosmospheric theory or theory of panspermia. According to this concept, life was brought to this earth from some other planet. The next one is the Big Bang theory related to the origin of universe. Origin of universe. Now the origin of universe occurred through a single, that is what's called singular, what is called huge explosion in terms of physics. So you have the earth, along with the universe we have the entire mass having some internal forces. They undergo what is called explosion. A single huge explosion resulted in the formation of many planets. So we have the origin of universe. This is because of, you see that one, a Big Bang that results nothing but a huge explosion. A single huge explosion resulted in the formation of the universe. Now if you are taking the primitive atmosphere, the primitive earth normally didn't have a proper primitive atmosphere. The primitive earth didn't have a proper primitive atmosphere. But we have various gases excepting oxygen. For example, ammonia, methane, hydrogen and water vapor. And this is not the first one. We had elements only in the form of metallic carbides, metallic nitrates, etc. I didn't go through all these things. So we had, though the primitive earth had no proper atmosphere, but it contained ammonia, methane, hydrogen and water vapor. Now we see that one, we have energy in the form of UV radiations. The UV radiation split water molecules into oxygen and hydrogen. So this is what is happening. The UV ray, they were the sources of energy responsible for breaking a molecule of water to form oxygen and then hydrogen. Now I already mentioned we have, that is what we call the water vapor. So the climate of the primitive atmosphere was extremely high. For example, if you are taking the temperature, it is about 5,000 to 6,000 degrees Celsius. Okay, even if you are taking the temperature, it is high. So the climate of the primitive atmosphere was extremely high, having high temperature of 5,000 to 6,000 degrees Celsius. Now we have sudden cooling of the earth occurred. So that what happened? The water vapor contained in the atmosphere condensed to form water, rainwater. The rainwater was showered and then accumulated in the depressions. Then they became what is called the water bodies. That's about the formation of water bodies. Now we have the formation of oxygen because of the splitting of water. Now the free oxygen combines with, the free oxygen normally combined with, that is what we have ammonia and also methane. It combined with ammonia and also methane to produce carbon dioxide and other gases, for example nitrogen, etc. I'll explain later about how far the reactions occur. So reaction between methane and also ammonia occurred, resulted in the formation of carbon dioxide and other what we call the gases like nitrogen. That's about what we call the Big Bang theory and the origin of different water bodies, the molecules, etc. Now cosmospheric theory or theory of panspermia. According to this concept, life was brought to this earth from some other planet. These spores are called cosmozoa or resistance life spores. So they came from some other planets from the universe and then just brought this earth and they developed into the first life. That's about cosmozoic theory. It is also called theory of panspermia. The concept was given by a person by name Arrhenius. So that's about the cosmozoic theory. But the most accepted theory of evolution regarding the origin of life, the most accepted theory of origin of life, not evolution, I can say in this way, the most accepted theory of origin of life in evolution, chemical evolution theory. Chemical evolution theory. Chemical evolution theory. The chemical evolution theory just normally explained by two people. One, Appari, A.J. Appari, another one, Haldane. These were the two people responsible for the development of chemical evolution theory, the most accepted theory of origin of life. It's also called as naturalistic theory. Now, what is just a concept behind that chemical evolution? Normally, origin of life is by means of abiogenesis, and the diversity of life is by means of biogenesis. Okay, so what is abiogenesis? We have seen already the development of complex organic molecules from inorganic chemicals. Now we will explain about the chemical evolution theory. Now the primitive organisms from the primordial earth evolved from what is called inorganic chemicals spontaneously. So this is nothing but theory of biogenesis. So formation of life, or what we call the primitive living organisms in the primordial earth, because of actually spontaneous, that is spontaneously actually from inorganic chemicals. The life originated from inorganic chemicals spontaneously. This concept is nothing but abiogenesis. And for the union of such chemicals to form a complex molecules like carbohydrates, proteins, lipids, nucleoproteins, etc., we need energy. So abundant energy was available in the primordial earth in the form of UV rays, lighting process, and then volcanic activities. They provided energy for the union of just all these inorganic chemicals to form a complex organic molecule spontaneously. That is the basic concept of chemical evolution. Formation of organic molecules or compounds from inorganic molecules with the help of energy provided by UV rays. They are in the form of physical forces. These are all the physical forces which provided energy. UV rays, then what we have the lightning also, and also the volcanic activities. I mentioned already two people, Appari and Haldane, explained what is the concept of chemical evolution. Appari in 1924 and then just Haldane in 1929. So the duration 1924 to 1929 to explain what we have the chemical evolution or chemical origin of life. Appari's view regarding the origin of life. He wrote a book what is called Origin of Life. In that one he explained the concept of origin of life. He suggested that the organic compounds were formed from the inorganic chemicals spontaneously with the help of energy, the physical forces like lightning, etc. Once the organic compounds were formed, they would have undergone a series of reactions, a number of reactions to form complex molecules. The formed complex molecules or the complex molecules formed, actually they develop into a colloidal aggregates, that is a paste-like substance scattering on the surface of seawater. Colloidal aggregates consisting of what we call the nucleoproteins, various macromolecules like carbohydrates, proteins combined together to form a paste-like aggregate. So the colloidal aggregates are called coadsorbates. Now coadsorbates means normally the colloidal aggregates which precipitate out in the aqueous medium. Only in the aqueous medium the colloidal particles get aggregated to form coadsorbates, and they are called the conservates, aggregates, large colloidal particles that precipitate out in an aqueous medium. Later they form what is called the pre-cells. Now these conservates absorb and assimilate the organic substances from the environment. That is called heterotrophic nutrition. They absorb and assimilate the organic substances from the environment. That's about the concept of that is a parent's view. Okay, now we have another person, Haldane's view. The next one, Haldane's view in 1929. He suggested that what is called the primordial sea was considered as what we call vast chemical laboratory. Vast chemical laboratory. This is nothing but the primordial sea, the one which existed in the past, primordial sea. So he suggested that the primordial sea served as a vast chemical laboratory, and the laboratory was actually powered by the solar energy. The energy for the chemical laboratory we have, that is a solar energy. Now we have the past atmosphere was that one free from oxygen. So no free oxygen is available. Now the combination of carbon dioxide, ammonia, and then what we have the energy UV radiations result in the formation of a large populations of monomers and polymers. Large populations of monomers and polymers in the sea. Now the sea is acting as a hot dilute soup. Hot dilute soup. The sea of the primitive atmosphere or the primordial earth considered as hot dilute soup or prebiotic soup. Prebiotic soup. Now this term was given by, that is what we have Haldane. So Haldane has given the term hot dilute soup for the sea with various organic molecules dissolved in it. It was also called as a prebiotic soup. Later what would happen? The various monomers and the polymers in the sea acquired a lipid membrane. Suppose this is what we have the conservates. They acquired a lipid envelope on a membrane, okay, which further developed into pre-cells. So, he considered sea as a most chemical laboratory. The energy source for the chemical laboratory came from what is called the solar energy. So, in the past, we had no actually free oxygen because the atmosphere was reducing atmosphere. The primitive atmosphere was reducing atmosphere. No oxygen available. The combination of carbon dioxide, ammonia and UV radiations resulted in the formation of a number of large populations of monomers and polymers which dissolved in what is called the sea. So the sea became what is called the hot dilute soup because it contained various organic molecules and the temperature was also high. Now they acquired a lipid envelope around and developed into pre-cells. This is the concept. Okay, he was a person who has given what's called prebiotic soup. And this term normally gave so this prebiotic soup, this term became what is called the largest power supply. Largest symbol of power we can say. Largest symbol of power or the symbol of power symbol you can say. The term prebiotic soup became the symbol of power of Haldane and apparent view of origin of life. So that was a concept developed by Haldane. And according to these two people, they independently suggested that if the primitive atmosphere was reducing atmosphere, if there was appropriate supply of energy, such as UV radiations, or we have the lighting, then a number or wide range of organic molecules can be synthesized. If the atmosphere was reducing, if there was abundant supply of energy source in the form of UV radiations or lighting, then a number of organic molecules can be synthesized. So that's about what we call the chemical evolution. The formation of organic molecules from the simple and followed by the development of what is called the prebiotic soup and also the aggregates of colloidal particles or that is co-aggregates. Now we have to go for how far the living system developed, that is the cells. That is what is called biological evolution. The chemical evolution of origin of life was followed by the biological evolution. Nothing but the first formed living cells, what are called the protobions. What's happening? We have already just formed the organic molecules which are formed by means of abiogenesis. So the abiogenetically formed organic molecules assemble, self-assemble into. So we have self-assemble into droplets. So we are forming the droplets and they enclose watery solution and they maintain a chemical environment entirely different from the surroundings. That is what is called the droplets. Immediately we had the formation of what is called liposomes. Liposomes are lipids in solution that self-assemble into, that is what is called bilayer of lipid, a bilayer lipid molecule. Now inside the liposomes we had some proteins which get converted into enzymes. So they acquire the properties of enzymes. These enzymes created biochemical reactions that resulted in the fast multiplication of organic molecules. So this is what happened. Now normally we have what is called co-aggregates. Then Haldane used the term what is called microsphere. Microsphere. So this is nothing but what we have the liposomes. The liposomes are also called as microspheres. Co-aggregates didn't have any outer membrane. Whereas the microsphere or the liposomes have an outer bilayer lipid envelope which encloses what we call the chemicals, and they are responsible for actually creating biochemical reactions. Normally you can see either the co-aggregates or microspheres. These are all the ancient particles with limited metabolic activity. Okay, that's about the biological evolution, the first part. We have to proceed further. What are the different types of cells formed? So formation of protobions followed by the formation of the mononeurons, and also we have the formation of that is a protista and followed by eukaryotes. Co-aggregates with the nucleoproteins and nutrients had outer limiting membrane that had the properties or the characters of viruses or free living genes. That means co-aggregates plus nucleoproteins plus the nutrients plus outer limiting membrane. Now co-aggregates, nucleoproteins, nutrients and outer limiting membrane together have the properties of viruses or free living genes. And subsequently what happened? The free living genes combined together to form protoviruses. Similar to those viruses, similar to the modern viruses. This is one. Now during that process, during that time, once after the formation of free living genes or the protoviruses, we had the formation of two types of cells. We had the appearance of two types of cells. So two types of cells appeared, which were more significant. One type of cell contained nucleoprotein, that is nucleoprotein clumps, mass of nucleoprotein that embedded in the cytoplasm without any outer membrane. And this is similar to what is called the cells of Monera. And now these Monera-like cells became the ancestral cells to blue-green algae and prokaryotes. The blue-green algae were the first photoautotrophs that formed during the origin of life, during biological evolution. We have the protobions, the brace cells, and they absorb organic compounds actually assimilated from the environment. So the first formed cell is heterotrophic. The first form of cell is heterotrophic. They didn't have chlorophyll. So by the development of bacterial chlorophyll, we have formed what is called monera-like cells, like what is called blue-green algae and prokaryotes. The monerans were the first, or the blue-green algae were the first. See, photoautotropic organism. First photoautotropic organism. Photoautotropic organism. So the first formed cell of the life is normally heterotrophic. Didn't have a chlorophyll, absorb the organic compounds from the environment, assimilate. But the first formed photoautotropic organism is blue-green algae. So the first type of cell developed contained nucleoprotein clumps at the mass embedded in the cytoplasm. That means there is no specific nucleus. As in the case of prokaryotes, we have nucleoid. That's the first cell. The second cell type, which contained the second cell type that appeared earliest one, that is contained nucleoprotein clumps. Mass of nucleoprotein, nothing but what we have, the nucleic acids plus protein. That condenses into central mass. So we have what is called the central mass of what is called the cells, surrounded by a membrane, what is called the nuclear membrane. Here there is no nuclear membrane surrounding what we have, the clumps of nuclear protein, but here the formation of nuclear membrane. So the central mass, that is nothing but the nucleoplasm, is separated by a nuclear membrane from the surrounding cytoplasm. So these cells represent what is called the protista. That is what is called protist. Eukaryotes, unicellular eukaryotes. And these are all, you know that one, unicellular prokaryotes. Okay now, so protist-like cells form. So the origin of life took place only in the sea. The first life originated only in the sea. When the food sources available in the sea declined, now these ancestral monerans and then protist, the ancestral monerans and protist evolved different methods of procuring food, different methods for procuring the food, either in the form of parasitism or in the form of animalism. Animalism means predation, or in the form of saprophytism, or in the form of chemosynthesis, or in the form of what is called photosynthesis. All these different modes of procuring food developed only because of the decline of, that is, food sources in the sea. That's why they have developed alternative, what is called this one. So what would happen now? Because of increased rate of photosynthesis, more amount of free oxygen added to the atmosphere. Now we have the unicellular protists. They have what is called, actually if you are taking the monerans, the prokaryotes or blue-green algae, they contain only bacterial chlorophyll. By developing what is called the true chlorophyll, we have formed the eukaryotes, and they produce what we have actually oxygen. So increase in rate of photosynthesis results in increased amount of oxygen. Now the formed oxygen, the free oxygen, combines with either methane or with ammonia to form carbon dioxide and nitrogen, etc. So we are taking for instance the first one, methane. It is being oxidized, resulting in the formation of carbon dioxide plus water. The second one we have ammonia. I am taking 4 molecules for balancing the equation. 3 molecules of oxygen that resulted in 2 molecules of nitrogen and 6 molecules of water. So the free oxygen already formed, reacted with either methane or ammonia and produced carbon dioxide and nitrogen gases. Now we have the free oxygen. The presence of free oxygen brought about the evolution of aerobic respiration. The presence of free oxygen just brought about the evolution of what is called brought about aerobic respiration. So the aerobic respiration yield more amount of energy when compared to anaerobic respiration. So the aerobic respiration resulted in the yield of more energy by the oxidation of the foodstuffs. Thus, as a result of all these events, now we have the eukaryotes formed along with the prokaryotes. So already the prokaryotes, now the eukaryotes formed by aerobic respiration. So these are all the different events that occurred normally during biological evolution. Remember that the origin of life took place only in seawater because it contained different elements. That is the one thing you have to remember that one. For biological evolution to take place, we need the replicators. The replicators are nothing but the genes. Only you have the free genes which have the power of undergoing mutation, we can get the different organisms. And also we need the partial isolation. Now the aggregates once formed, they should be separated from the seawater. And also we need high temperature to create mutations. In the past, temperature was one of the mutagenic agents that caused mutations in the free genes that resulted in the formation of a number of replicators. Replicators, the word referring to what is the genes. So different genes are being formed, and because of the protobionts, the first free cells, actually the first living cell is heterotropic in nutrition, using organic compounds, assimilating the organic compounds from the environment. The next one, photoautotrophs, primitive photoautotrophs. The primitive photoautotrophs are blue-green algae. Then we have, that is what's called advanced or eukaryotic photoautotrophs, nothing but the green plants. Also you have the unicellular algae like Chlamydomonas, etc. So these are the different events that took place during the evolution of what is called actually life. So biological evolution. So we can conclude one aspect. The origin of life is by means of abiogenesis. So we have received the primitive cells. And the diversity of living organism, for example, either from amoeba to different complex organisms, is by means of biogenesis. The existing living cells gave rise to, that is what we have actually said. The primitive living cells gave rise to the existing cells. So I conclude with one sentence. The origin of life is by means of abiogenesis, formation of organic compounds from inorganic chemicals. And once a cell is formed, it undergoes diversity, different complex organisms being formed. So the diversity of living organism is by means of biogenesis, because now the existing living cells came only from the pre-existing living cells. That's a conclusion regarding the origin of life. So I'll go to the next part, then the next class. Till then, goodbye. Thank you.